Guys, in this video I will start drawing the structural components of the warehouse. Now it's very important just to point out what we're learning in this course, how to translate the actual design into drawings. In other words, this course is not to determine the sizes or the components we will be using for a warehouse design. Please don't use or don't assume any of these sizes we'll be using today in this tutorial as a fixed size for this type of members, or this is the only way that we do it. Usually the process of this design will go by the design engineer first, and the design engineer will create all the calculations and will come up with sizes for different members, and then he will use these sizes into the drafting process. So usually a draftsman or a designer will get all these sizes from the design engineer, all specified and selected, and I'm just using a random sizes now where appropriate, obviously sizes where appropriate to the size of this warehouse. Having said that, I don't want you to assume, please, any of these sizes are fixed, or this is the only one size, or this is the only one member that we use for these type of designs. Okay, there's a huge variety of shapes, sections, sizes that we may use in this type of design. Okay, so the specification, we're assuming the specification that we got from the design engineer, that for the main portal frames we'll have, this is 6 equally spaced, actually 7 equally spaced frames that will create 6 bays. The rafters and the columns are made of a 530 UB82, a universal beam 530 UB82. Okay, that will be for the columns and the rafters of the warehouse, of the mainframe. We've got further specification here regarding the base plate, the bed footings. We have got some more specification here regarding the connection between the two rafters at the apex point. We've got the connection between the rafter and the columns. We've got the short wall specification, the columns on the short walls or the short elevations at this location here. We will have a series of columns. Those usually are smaller than the columns located on the longer walls, because these columns on the longer walls will create the portal frames or the sway frames, so they are rigid columns, whereas on the short walls those are just to support the end wall from the wind pressure, so it will be slightly smaller columns. The specifications for those will be 310 UB40, universal beam 310 UB40. We've got specs here regarding the other components in the warehouse. This could be slightly different than what we used in your class. Please just start a new drawing and practice these sizes with me if you'd like, or you can stick with the sizes that we used in the class. Shouldn't be a problem at all. Okay, so we've got the S1 referring usually to the struts. Usually the struts are placed in the roof and wall frames to provide the compression between frames, the spacing between frames. They transfer compression forces between frames. These struts are made of 75 by 6 square hollow sections. We've got some connection details for those. We've got the bracing for the roof, 20mm rods, 20mm diameter rods, and we've got for the wall vertical bracing, we've got 75 by 75 by 6 equal angle, and for the door beam 360 UB 44.7 flipped. We'll discuss that when we get to it. And for the fly brace, we've got 55 by 55 by 5 equal angle. We will discuss that too when we get to it. Purlins and girts, we are using C219 C sections, 200mm deep and 1.9mm thick, spaced at 1200 centers for the purlins and spaced at 900 centers for the girts. Okay, so we've got the specification here. Regardless, the main component we need to start with are the rafters and the columns, and that will be our starting point on Revit. The first thing we need to start drawing are the, or modeling are the columns. So if I go to structure, make sure that we're going to structural tab, not the architecture tab. So we'll go to the structural tab, we choose columns. The specification here is showing me a universal column UC 305. That's not the size that we want, so we go to load family. Now all this library here, what we've got is the US Imperial sizes. That's not the sizes or the library that we want to choose from. If I go one step up, I can't find the Australian library here, and this could be the chance for some of you. I told you to copy the Australian library from the computers at TAFE. Having said that, if you didn't do it, what can we do to get the library? Just you have to go online and search for Revit 2020 contents. Press enter. If you click on the first link, Autodesk Revit 2020 contents, that will give you the download page for a list of countries. We want the content for the Australian library. Just press on it and that will start downloading your library into your computer. Simply that will download a self-extracting file. As soon as you get this loaded to your computer, just give it a couple of minutes until it will be loaded to your computer. The minute that will be loaded, we will extract that file and get the contents of this file to be located in the right position. You can read the steps here if you would like to, but anyway, I'm going to do it now in front of you guys. So just waiting for it to download. Okay, so the file is fully loaded now. All I have to do is just click on the file and that will open the self-extracting file to start copying the library in the right location for you for Revit. The right location should be in C Program Data Autodesk Revit 2020. Okay, just open my second screen saying this is the specification and this is the location where these files will be copied, which is exactly the same location here. Say extract. Because I've got it already done before, I'm just replacing it. I'll say yes to all. You may not get that message, just start downloading straight away into your computer. Okay, that's it, it's done. So if I go back to Revit now, as you can see in the libraries, a new library showed up under Australia. If I click on it, now I've got all the components for the Australian structural members. Okay, so we going back to what we were doing. We were loading, or we were placing the columns. So we have to choose the right column first. So we load a family. I'll go to the Australian library. Very important, guys, to note again, I did mention that in the class, but just in case you forgot, structural columns are in a different folder comparing to all structural components, which would be under structural framing. So beams, bracing, struts, all of those would be under structural framing. The only one component will be separate from those is the structural columns. So we are placing columns. We go to structural columns, steel and Australian standard. We go to the universal beams to be used as a column. Okay, the universal beams here referring just to the type of the section. Doesn't mean they are only used as beams. We can use UB as a column when we need this column to have a good bending moment capacity. So I'm using the universal beams 530 UP80 if you remember. So I'm just clicking on that and I'll choose the right section, 530 UP82, and choose OK. We loaded the right size. Now we've got the specification here to inserting the column at what level, and we are working with floor level. So it's saying here, shall we specify the depth or the height? We can just specify the height, and we can connected to the eave line, the top of the column, and we just place the column. As you can see, the column straight away will snap to the intersection between the two grid lines. So I can place the column here. If I look at it in 3D, this column will be placed from the floor level all the way to the level of the eave line. If I look at it on the elevation, that's where the column will be placed. Now, it doesn't have to be that complicated really. You can just place the column and amend it later on. For example, if I go back and choose a column, rather than having all of those specification, imagine it was as is before. So regardless of, we usually when I place columns, I don't look at it too much because I go back and fix the location and the height of these columns. So if I place the second column here, the opposite direction of the first column, so just on the intersection of these two grid lines, press escape a couple of times to exit that. If I look at it in 3D, it's not the right arrangement for our column, but that's easy fix because we can just simply, if we have these two columns the same, so if I look at them from one of the elevations or from the 3D view, by selecting this column, I can go to the property menu here and fix the column. So the base level at the floor level, that's right. And the top level we want it to be to the eave line. And the base level we want it to start from 0 at this point. We will change that down the track, but at this point we want it to be at 0. Just wait for it to update and that will be exactly the same outcome of what we had before. Okay, so there are too many ways of inserting columns or placing columns in the drawings. If I have a large number of columns to be placed, for example, which is we do here, but at the same time we will place them as frames. So my plan is to work on this frame first, the entire frame, create the two rafters here, and then start copying them around or repeating the same process again. But in case we will have a situation that I need to place multiple columns at these grid lines here, there's another function. We can just place a column at grids intersections. So I can just select these grid intersections here, and by press finish, look at that, all these columns are placed at the intersection between these grids. If I look at it in 3D, and then I can just simply go to them and select these columns, fix them the way we fixed those before. So to the eave line at the top and 0 start on the floor level. That's it. So there are easier ways if we have a large number of columns to be placed. Having said that, at this point of time we don't need those. As I said, I'm going to work on the first frame as we've done in the class, and then copy that frame because all the frames are identical almost. So I'm going to finish the first frame all together and then copy this frame all around. Okay, so we have the columns. So if I look at it from the west elevation, I have the columns placed, and now I need to install the beams or start drawing the beams. As we know, the beam would go from this point here, the connection between the two columns, all the way to the apex point. So it's the easier way to draw these beams to go to the west elevation where I can see these two rafters. To draw those, I'll go just to beam. There are the shortcuts, by the way. Just to highlight, there are the shortcuts on the keyboard, which is I usually use. It's up to you if you want to get used to them, and if you want to learn these shortcuts, you can just press KS, like keyboard shortcuts, the first two letters of that, and that will show you all the shortcuts that you can use on the keyboard. So you'll find, if you go through them, you will find for a column, if I go back to FL and press CL, that will straight away activate the column function. Or I can, for the beam, for example, BM, this is what we are drawing now. So if I go back to the west elevation, I need to draw a beam of type BM, asking me what plane do I need to use for drawing these beams. I'll choose the plane as we discussed. If I'm working with the west elevation and I can see numbers here, that means I can, if I choose the grid A will be the right plane that I need to draw in. So grid A is our plane. I'll choose that. And what size beams we're going to use, the same thing. Keep an eye on the sizes, please. We should load the right size for the Australian library. So I load family, Australian standard. Having said that, don't forget we are still within the column. Look at it, it's all saying column. Because if I choose that, for example, if I try to choose UB, we are still in the column folder. If I choose universal beam column and try to insert that, that will not be inserted. Will give me, this is the wrong side, the wrong section. So what we need to do, load the family and go out of this folder back to structural framing instead of structural columns, and we got steel, Australian standard and universal beams. I'll just show you again. Look at that. When we are in that folder, if I go back all the way to Australia, structural framing, steel, Australian standard, UB, doesn't say anymore universal beam columns, it's just universal beams. This is the members that we're looking for. So we go to 530 UB82 based on the specification. Both rafter and column are 530 UB82. This is the size we are after. And now asking me, just save the project. Every now and then it's a good idea, guys, to keep saving. So asking where do we need to draw the, keep an eye please on these notes here at the bottom of the screen. It's always giving you steps and direction and instructions to what we need to do first. It's asking, specify the start point of the beam. So I'll go from this point here to the apex, and from this point here to the apex again. And that will draw our rafters. Escape a couple of times. If I look at it in 3D, we just created the one frame for our warehouse. Now, minor things that we can look into. As you can see, these colors here, these are referring to the analytical properties of these members. This is nothing of our concern at this point here, because we are just using this software for drafting only, not for structural analysis. So that's why we're going to turn this function off. Okay, from this button here at the bottom to show the or show or hide the analytical model. We can change the properties of the graphic properties of the model from here. We can show the wireframe, which is assume that all your members are made of glass, you can see through them, or see through view. Or we can look at the hidden lines or shaded. Mainly wireframe and shaded are the two common views that we use. So if I show shaded, you can see the difference comparing to wireframe. So stick with shaded for now until we need the other view. We've got the level of details. We have coarse, medium and fine level of details. Usually the fine level of details showing all the connections, all the details of bolts, weld, all of those. If we go to coarse and medium, that will hide some of them just to make your model lighter, so for your computer to apply updates quicker, to rotate the model in an easier way. Okay, so at this point we can keep it on fine for now. Alright guys, this is the second part, just to draw a one portal frame and discussing the column and beam functions really. We will start the third video tutorial just to start building up on our model.